In this video, I'm going to talk about motion, distance, and displacement. These are the three basic terms that forms the basis of classical physics. Uh, motion, motion, distance, and displacement. So let us understand the motion first. What is motion? When do we say that the object is in motion? Whenever you see something and if you see that it is moving from one place to another or it is changing its place, then we can say that that object is in motion. But to be very precise, we need to give some sound definition to the motion. Okay, suppose you are standing over here and this is some ground and you are obviously standing on the ground. Okay, and you are playing with some ball and you threw the ball, you rolled the ball in this direction, and ball is rolling like this. So ball is rolling like this and is moving in this direction. Then you would say that ball is in motion. How do you know this? That is just because ball is changing its position with respect to you. Ball is changing its position with respect to you. So now we get the definition of motion. Whenever any object changes its position with respect or with reference to some stationary object, then the object or the former object is said to be in motion. Okay, so whenever any object changes its position with reference to some stationary object, then the first object we were talking about is said to be in motion. In this case, the ball is moving when this person standing over here, most probably this is you. Yeah. So the ball is changing its position with respect to you. That is, initially it was over here, then after some time it would be over here, then it would be over here, then it would be over here. So it is constantly changing its position. Hence, we can say that the ball is in motion. Okay. Now, this was all about motion. Now the ball is over here initially, and after some time you find the ball to be over here. And what is this? This is called distance covered by the ball. This is distance covered by the ball. Okay, the distance is basically nothing but the difference, the length of the path that the ball is moved. Okay, then what is displacement? In this case, displacement would be same as distance. It is just the distance between the initial position and the final position. Now I'm sure some of you must be having a doubt that what is the difference between distance and displacement. So we will understand this with some another figure. Difference between distance and displacement. Okay, again I would take you as an example. This is you, and you are standing at point A. Okay, this is point A, and you're just standing near it, and you start moving in this direction, in the horizontal direction, and you reach at point B. At point B, you took a right turn and start moving in this direction to reach some point C. Okay, now just let me join points A and C. Okay, now this is the right triangle, and just don't think anything about Pythagoras theorem or something. We are not going to work with that right now. What I want to say is AB is say 5 kilometer and PC is say 3 kilometer. Okay, AB is 5 kilometer and PC is 3 kilometer. Then distance covered. Distance covered would be 5 plus 3, 8 kilometer. Okay, distance covered would be 5 plus 3 is equal to 8 kilometer. That is the actual path that the person, that is you, have traveled, that I am showing with a yellow line. This is the actual path you have traveled. You started traveling from A, then reached B, and then went up to C. So this is the total distance that you have covered. But if I want to give the displacement, that I am going to show in, say, magenta color, then this would be the displacement. This is displacement. That is, it is the distance between the initial position, that is A, and the final position, that is C. So no matter what path you are taken, but it is simply a distance between the final position and initial position. So what it would be, that is so 25 plus 3 square 9, so 25 plus 24, so it's under root of 24. Sorry, I made some mistake, calculation error. This would be 25 plus 9 is equal to 34, and so this would be under root of 34 according to great Pythagorean theorem. Okay, so this would be under root of 34. So our displacement is under root of 34, whereas our distance is 5 plus 3 is equal to 8. So this is the difference between the distance and the displacement. Let me repeat this again. Distance is the actual length of path that you travel. So A to B and B to C, that is the distance. Displacement is simply the displacement is simply the length or the distance between the initial position and the final position when we connect them directly by some straight line. So if I take some other path, let us say, let me erase certain things. I'm not going to, I'm erasing you right now, and this all things. Okay, now instead of going from this path, you decide to choose this path. You first go from A to some point D, then you move from D to some point E, and from E you move to point C. Okay, then the total distance would be AD plus DE plus EC. AD plus DE plus EC. But your displacement would still remain A to C, that is the distance between final and the initial position. I hope that clears the concept of distance and displacement. Now the prime difference between distance and displacement is distance is scalar quantity. That is, it simply has a magnitude along with its unit. So this is called the magnitude of distance, and this is a unit, whereas displacement is a vector quantity. So you need to define the direction. You need to define the direction along with the magnitude. So consider this Cartesian coordinate system, and there is some object that's moving in this direction. And it's covering distance 5 kilometer at some angle of 30 degree with respect to horizontal x-axis. So what we say is, if we say that the object has moved 5 kilometer, then what we mean to say is distance. But if we say that object has moved 5 kilometer at angle of 30 degree with respect to horizontal axis, then we are defining the direction also, and in this case it would be called as displacement. So a scalar quantity is simply a magnitude with its unit, and displacement is a magnitude, unit, and direction too. So this is the difference between scalar quantities and vector quantities. This is a lower level physics series. If you are looking for detailed instructions about what are scalars and what are vectors, it will be covered in a higher level physics series that you can find in the separate playlist. For this video, thank you. uh, in next video we will carry forward about motion only. Thank you.